Yo, you're right. It's Tommy Allen here, and today we're going through the kind of 7th tutorial of the Wise Reflect and Unreal Engine integration, and today we are looking at dynamic reverbs. And what dynamic reverb means is we can keep using the same volume or reverb settings, and it's going to change based on the parameters we choose. So let's just hear what that sounds like in person. Pick up my gun. Okay. Really short reverb on that. And we've got the same reverb in this room. And it's a lot longer. Okay. And they're both using short reverbs. Okay. So I'm just going to show you that if you don't believe me. Windows. Ooh. Dig. Details. Okay, so they're both using the short reverb. And yeah, short reverb. So as you can see on here, we've kind of got these parameters: decay, time to first reflection, and HF damping. Okay, and these are kind of what Wise implements every time you put down a cube or a spatial audio volume, and we can send those to Wise to change the parameters, what we've just done. So I'm going to show you how to set that up. So let's go to Wise. And I'm going to drag this over. Oh, no, that's the OBS. Let me drag this over. Okay, and in game parameters up here, I've made decay, HF, damping, and delay. So decay is just your RT60, how long it takes to decay. HF damping is the frequency, so high frequency damping. So if you've got like cushions, it's going to affect the reverb a bit differently than brick because you can have different frequency content. So that's the high end being lost, and pre-delay is the time to the first reflection. So how do you create these? You just right click, child, game parameter, boom, and you can call it delay 333. Okay, but I've already created these, and what we need to set these up as is our decay is from our decay is from 0 to 10, default 0. Okay, that's because it goes from 0 to 10 seconds. We're not going to have a RT60 or a decay time over 10 seconds. Our HF damping is from -1 to 1, default 0. And pre-delay is from 0 to 1. Okay? And default 0. So after we set that up, we need to then go into our audio and go to our reverb, and if we double click on our reverb effect, okay, it will bring up this window here. As you can see, there's our settings, and if we go to RTPC, we can start adding in decay time, reverb, we'll add HF damping, and we can add in some pre-delay, and they're the game parameters we've just made. So let's go to spatialization, decay, HF damping, and game parameters, pre-delay. Easy peasy. Okay, one thing for this, it likes to kind of put at 0.114. I don't know why it does this. It's really annoying. Okay, so drag this out a little bit and drag this all the way down. So at 0, we're getting 0.2. That's the minimum amount of decay time we can have. I don't know why it always puts it here, but it doesn't sound right, especially when you've got lots of little small rooms. And then we just drag this all the way to the top. That's our decay time sorted. Our HF damping. For this, this is what it said on the website to use. But I guess high frequency damping starts ramping up at the bigger distances we go, or the kind of more heavy materials. And for pre-delay, 0 to 1. And our pre-delay is set in milliseconds, and our pre-delay is set from 0 to 1. Okay, let me just check the pre-delay. So pre-delay is in 6.29 milliseconds. So I'm actually not sure how this is going to work, but I'm going to double check, and we can do it by just testing in our voice profiler. So that's all fine. Let's go into our project. So now we set up the RTPCs. Now we need to make sure our project knows to send these values here to the actual game parameters. So in project settings, if you click the edit and go to project settings, go all the way down, integration settings, and these have already been made. So HF RTPC, usually these will be blank. Okay, so the game parameters that we've just made, we can input these. So for damping, we want our damping. For our decay, we want our decay settings, and time to first reflection is pre-delay. It's very basic setup. Time to first reflection is kind of the minimum pre-delay. Yeah, I'm not going to get into maths. Anyway, so that should be now done. We're going to force asset synchronization, generate sound data, boom, and it should all be working now. Okay, so let's just hear that. So boom, no reverb, tiny bit of reverb, and you can hear that. So if we go into our voice profiler, and we actually link up the game, okay, I'm just gonna play it a little bit over here. I'm gonna pick up the gun. Where's my gun? Okay. Easy, nice. Okay, so if we go into our voice profiler, we can actually see what is happening. So yeah, along here, there it is. So our decay time, our reverb volume, so that's 85, and that's this one here, that's 85 here. We can see that it's set to a decay time of, I think, 1.3, which is about right, and our volume 84, where are you? Down here is 0.235. So you can see they're a lot different. Okay, so far we've got most of the HF damping are all the same apart from the volume 85. So the way this is calculated is, for this I used a different material. Okay, so if I go back into Windows details, when we change the material of what this is made out, I think it's currently made out of brick, surface reflectors, brick, we'll start changing the HF, the damping. So if we change it to fabric, okay, and we come and have a look, usually the actual settings of the parameters lie on like kind of the top, and as you can see, the damping has gone to 0.32. If we change this down to mountain, 0. Okay, wood. One of the yeah, so wood actually is really reflective in the low end. So that's how we have the minus numbers. So yeah, that's what it does. That's pretty sick. One of the unfortunate things that I found about this is the material, I don't think really affects RT time. Okay, so if we actually have a look at our decay in seconds, if I change it from wood to anechoic, which is like all reflections are lost, it doesn't actually change the decay in seconds, which is a bit annoying. But let's just hear what that sounds like. It's meant to be an anechoic chamber, so anti-anechoic, or anti-echo, but yeah. So I think there's actually need to be a bit of a workaround for changing these absorption coefficients on each side of these, because it's changing the HF damping, but it's not changing the actual reverberation time, as you would expect. Like if this was all made out of tile, we'd have a different story, but it will reduce the RT kinda by taking out sections of the frequencies. So if you take out the high end, it's going to seem like it's a bit quieter. Anyway, yeah, so that's how you set up the dynamic reverbs. Easy. Awesome. So I hope that was useful. I hope it was quite quick. Yeah, for just a little note, in the kind of documents on the website, it says you can copy and paste these into, say, long reverb, and it's going to work. It doesn't. So you can't copy and move them. You have to kind of reset them up, which is annoying. Not sure why. That was just my workaround, and it seemed to work fine. So yeah, that's how you do dynamic reverb, and I will see you laters.